Okay, we are live. So, a very warm welcome to everyone for today's Consciousness and Reality Colloquium. This is the second lecture in the CNR series for this academic year. And we have about 40 or 50 participants right now. They're still trickling in. Our participants are from Caltech, MIT, Stanford, and IMIX. And I am Kunal Mole, an astrophysicist and co-founder of IMIX, which is the Institute for Mind, Intelligence, and Consciousness Studies. And this colloquium series seeks to inspire interdisciplinary investigations on topics such as mind, cognition, consciousness, and the nature of reality. So consciousness really has been investigated from various perspectives like neuroscience, biology, cognitive science, psychology, philosophy, and physics. And many varied notions of consciousness and reality have emerged from these various disciplines. But only a few researchers have really probed these concepts from an interdisciplinary approach. Our speaker here today is one of these few researchers. So just some quick points before we introduce our colloquium speaker. Select questions from the Q&A box will be taken after the talk. So I encourage all of you to submit your questions through that Q&A button that you may be able to see at the bottom of your Zoom window. And as with previous colloquia, we are going to make this interactive and fun. So you can click on the poll button below on the Zoom window again to answer two simple questions, which are yes and no type. The first question, so let me first launch this poll. Uh, okay, so let's hit launch. And all right, so I think you all may be able to see this in your screen or when you hit the poll button. And there are two questions there. Again, simple yes, no kind. The first question is consciousness is fundamental and causes brain activity. And the second one is reality may be completely different from what our brains model and perceive. Okay. So simple yes, no questions. Um, you can answer them whenever over the next 40-ish minutes. And I will announce the results of the poll at the end of the talk. Okay. Uh, all right. So, and to introduce our speaker today, Donald Hoffman is a professor of cognitive science at UC Irvine with joint appointments in the Department of Logic and Philosophy of Science and the School of Computer Science. Donald's research spans consciousness, visual perception, and evolutionary psychology, and he uses mathematical models and psychophysical experiments. He has authored a few books, some of them titled Observer Mechanics, Visual Intelligence, Automotive Lighting, and Human Vision. And his most recent one, which is The Case Against Reality, How Evolution Hid the Truth from Our Eyes. And he has also appeared in popular series such as Dead and the PBS show, which is Closer to Truth. So, Donald, it is a great pleasure to have you today, and the stage is all yours.
Thank you very much, Kunal. I'll share my screen. I'll have to turn off. The poll is on my screen here. There we go. Okay. So my talk is Consciousness and its Physical Headset. And that title is to contrast with what most think, which is, see, I'm getting that poll again. That consciousness has a physical substrate, consciousness and its physical substrate. So I'm going to explain why I'm talking about a physical headset instead of a physical substrate. So most theories of consciousness that are popular today assume that space-time is fundamental and that particles inside space-time, elementary particles or objects made out of them, create more macroscopic objects such as brains, neurons, and these in turn create, if they have the right kind of structure and complexity, they will create our conscious experiences. So I've listed a few of the current theories that assume this, physicalist theories. Some assume that they create conscious experiences, or others say there are no such thing as conscious experiences, but they create the illusion of conscious experiences. Panpsychist theories will often assume that space-time is fundamental and that there are elementary objects in space-time, elementary particles, and that some of these elementary particles have underneath them as their underlying reality, conscious experiences. So panpsychism, as I'm talking about it today, assumes that some fundamental physical objects in space-time have consciousness. But high-energy theoretical physicists now tell us that space-time is doomed. By that, they mean it's not fundamental. And I'll just quote a few and then I'll explain why. So Ed Witten at the Institute for Advanced Study at Princeton says space and time may be doomed. Nathan Seiberg says, I'm almost certain that space and time are illusions. These are primitive notions that will be replaced by something more sophisticated. Andrew Strominger at Harvard says the notion of space-time is clearly something we're going to have to give up. David Gross, winner of the Nobel Prize for his work on the strong force, says, I believe that space for sure, and presumably time as well, will be emergent. And Nimar Kani-Hamed at the Institute for Advanced Study says, the very notion of space-time is not a fundamental one. Space-time is doomed. There is no such thing as space-time fundamentally in the actual underlying description of the laws of physics. And David Gross explains why. The reason why space-time is doomed, at least one of the primary reasons, is that there's no operational meaning to distances smaller than the Planck length. And what they're saying is this: suppose that you're trying to measure smaller and smaller objects. Well, to do that, you need bigger and bigger microscopes, which can make finer and finer wavelengths of light, or whatever radiation you're using. So smaller wavelengths of light or radiation to resolve finer details of the objects that you're measuring. And that's fine. We know that you need more energy to make smaller wavelengths, but that's perfectly fine in quantum theory. But gravity spoils the party. As you go to finer and finer distances and you're getting smaller and smaller wavelengths of light, the energy is going up to the point where you have so much energy in such a small region of space, and energy and mass are the same thing according to Einstein, that you actually create a black hole and you destroy the very object that you're trying to measure. So by the time you get down to 10 to the minus 33 centimeters or 10 to the minus 43 seconds, there is simply no operational meaning to space-time at all. And if you try harder by making smaller wavelengths of light, the black hole you create just gets bigger and bigger. So space-time can't be fundamental. It falls apart at 10 to the minus 33 centimeters. And from my point of view, that's pretty shallow data structure. It falls apart at 10 to the minus 33 centimeters, not 10 to the minus 33 trillion centimeters, just 10 to the minus 33. And we'll talk a little bit more about what the physicists are doing about this, but high energy theoretical physicists are now saying space-time is doomed, and they're looking for structures beyond space-time. It's not fundamental. But remarkably, evolution by natural selection agrees. So evolution by natural selection, we can ask a clean technical question using evolutionary game theory. Does natural selection favor veridical perceptions? That is, perceptions that are homomorphic to whatever structures reality might have. And one can answer this question using the mathematics of evolutionary game theory, either using simulations or actually proving theorems, and we've done both. And what we find is that organisms that see reality as it is, their perceptions are veridical, they go extinct when they compete against organisms that see nothing of reality and are just tuned to fitness payoffs. So evolution shapes organisms to have sensory systems that guide adaptive behavior, period, not to see the truth. And so what evolution has done instead is sort of give us perceptions. Instead of being a window on reality, they're more like, say, a desktop on your computer. When you're writing a paper or sending an email or something, what you're doing inside a supercomputer or whatever computer you're using, a laptop, is toggling millions of voltages in some kind of precise order. But if you had to do that, you would never get your work done if you had to toggle those voltages. So the user interface, the desktop, lets you do change reality as you need to, toggle those voltages without even knowing what you're doing. And that's sort of what evolution did. It gave us space and time and physical objects as just a nice user interface that lets us interact with reality as we need to survive without needing to know the details of that reality. So seeing the truth won't make you more fit, it'll make you extinct. And not seeing the truth frees you up to play the game of life and win. So you can also think of it instead of a desktop, think of space, time, and objects as a virtual reality headset that we wear, and we're playing the game of life. Just say we're like Grand Theft Auto or something like that. Um, we see um, steering wheel and we see cars and so forth that we're playing in the game. We might see our own avatar in the game, and these are all just useful symbols inside the headset. They're not the reality. In this metaphor, the reality would be some supercomputer that's running the VR simulation. So evolution has given us a little VR headset, and that's why my talk title was about consciousness and its space-time headset or its physical headset. So the car that you see in the VR game is only there when you look, and as soon as you look away, it's no longer rendered, and so it doesn't even exist. So local realism is false. Objects don't exist and have definite properties like position and momentum when they're not observed. That sort of falls out of this whole approach that local realism is false. So now returning to the high energy theoretical physicists, they tell us not only that space-time is doomed, but that as a consequence, reductionism is also doomed. And reductionism is the view that as you go to smaller and smaller scales of space, you find more and more fundamental objects and more fundamental laws governing those objects. That's reductionism, and it's been fantastically successful in certain aspects of science. But now many high energy theoretical physicists are saying space-time is doomed. As Nima puts it, so the entire reductionist paradigm that fundamentally physics is given by some laws at the ultra most microscopic distance scales, and that somehow we just have to go there to see what's going on, is ultimately false because of gravity, right? Because gravity creates these black holes that destroy space-time. So reductionism in physics is actually now dead. And so the reductionist paradigm in science is a long history. We used to think earth, air, fire, and water were the fundamental reductive elements of reality. And more recently, we thought the periodic table of elements was the most fundamental elements of reality. And now we have the bosons, leptons, and quarks of the standard model of physics as our current model of the fundamental elements of reality. But what the high energy theoretical physicists are saying is that the entire paradigm of space-time being fundamental and having fundamental objects inside of it has to go. That whole paradigm is gone. But that paradigm is not yet out of the minds of people studying consciousness, right? Most theories, as I mentioned earlier, assume that consciousness is based on a physical substrate, that space-time is fundamental, that elementary particles create, more complicated objects like these pyramidal neurons and other glial cells and other neurons. There are thousands, we've discovered thousands of different kinds of cells in the brain. But they create structures like the brain, which then gives rise to conscious experiences somehow. And this is the view of, I would say, my guess is 98, 99% of all the theories of consciousness today assume that space-time is fundamental. I list a few of these here, and that space-time gives you the substrate for consciousness somehow, or the particles that consciousness is the fundamental reality behind in panpsychism. But these theories have what I'll call the stipulation problem of consciousness. And this is from a book by Pinker, I think Enlightenment Now in 2018. Pinker likes the global workspace theory of consciousness, but in his book he points out, but the last dollop in that theory that it subjectively feels like something to be the circuitry may have to be stipulated as a fact about reality where explanation stops. And Pinker is pointing out something that's true of the global workspace theory, but of all these theories, and that is that these theories um, cannot explain any specific conscious experience. So, for example, what is the specific, structure of a global workspace or contents and broadcasting structure of a global workspace that must be the sound of a saxophone and couldn't be the sound of a trumpet? Or what is the pattern of integrated information, the so-called Q shape that must be the smell of a rose and couldn't be the smell of chocolate or something like that? In every theory that you come up with, say the orchestrated collapse of quantum states of neuronal molecular tubules is Hameroff and Penrose's theory. So what precise orchestrated collapse of quantum states of neuronal molecular tubules must be the taste of chocolate and couldn't be the taste of vanilla? There's not a single specific conscious experience that has been explained by these theories, not one. So theories of conscious experience that have yet to explain even one specific conscious experience. So that's the stipulation problem that Pinker is pointing to. And I agree with Pinker that these theories are interesting, but when it comes right down to it, they stipulate space and time. They stipulate certain neuronal processes or microtubule processes, and then they don't explain the conscious experiences. They have to stipulate those as well. So everything is stipulated, and no conscious experience, no specific conscious experience is explained. So reductionism is doomed, and space-time is doomed, and that's why I think this failure is not due to lack of intelligence or lack of effort. My colleagues doing this work are brilliant. Many of them are geniuses. They're failing because it can't, in principle, it cannot be done. Space-time is not a substrate for consciousness, and reductionism is dead. High-energy theoretical physicists are telling us this. So, but they're telling us something more, which is also surprising. It's not just that space-time is doomed, but also that quantum theory is not fundamental. As Nima puts it, so there's some other structure that we're looking for beyond space-time, and some way of thinking about that structure or interpreting the structure that will let us see space-time and quantum mechanics emerge simultaneously and joined at the hip. So it's not, the current trend is not to think about space-time being emergent from quantum theory, but that space-time and quantum theory emerge together from something deeper. So Nima says we're going to have to look for structures and ideas that don't look anything like anything having to do with particles propagating in space-time and wave functions evolving in Hilbert space. So this problem, in other words, goes very deep. Space-time is doomed. Quantum theory is doomed. We need to look for some new structures beyond space-time and quantum theory. Well, they've been doing that, and they've been succeeding just in the last 10 years. So the high-energy theoretical physicists have made some dramatic discoveries just in literally in the last 10 years. They have taken off the headset, space-time headset, is not the fundamental reality, and they're saying what's beyond space-time. And they're actually finding new structures that explain critical things in high-energy theoretical physics, like scattering amplitudes. Like what's the probability or the amplitude for 2 gluons smashing into each other and 4 gluons spraying out, things like that. So in 2013, and published in 2014 in a journal, they discovered this structure called the amplituhedron. And this is a geometric structure entirely outside of space-time. It's not something curled up inside the extra dimensions inside space-time. It's utterly outside space-time. And its volumes give you scattering amplitudes, and its phase structure gives you properties of space-time like locality and unitarity. And they also have found, in addition to structures like the amplituhedron, they're finding combinatorial structures that classify the new structures outside of spacetime. In particular, something called decorated permutations, which are permutations in which each fixed point of the permutation can have two states of the fixed point. We can go into it if people have technical questions. So the idea is that that space-time is not fundamental. Space-time is doomed if you're thinking about it as a fundamental structure, that's doomed. But beyond space-time, they're finding these geometric structures like the amplituhedron, associahedron, cosmological polytopes, and other structures. There's the so-called positive geometries. That's what the new field is called, the positive geometries outside of space-time. And then combinatorial objects like decorated permutations, especially decorated permutations, that classify these new positive geometries they're finding. But we're in an interesting position now. This is brand new. It's only in the last 10 years. So we've gone outside space-time, we've taken off the headset, and we're finding these new geometric objects, these positive geometries. But they're like the monoliths in 2001: A Space Odyssey, right? Where the apes they see this monolith, they're hooting and hollering, pounding on it. They know it's really important, it's meaningful, but they don't know what it means. And that's sort of where we are right now. We have all these, just in the last decade, found all these geometries outside of space-time, but no dynamical notion. What dynamics might give rise to these objects, and what do we mean by dynamics of beyond space-time? What kind of entities beyond space-time could we be thinking about? So we're in a very interesting position here. And as a result, the European Research Council just has recently announced their Universe Plus project. I think they put 10 million euros into it so far on positive geometries in particle physics and cosmology. Here's part of the announcement, and I'll just put up some quotes. The project seeks a new foundation for fundamental physics, ranging from elementary particles to the Big Bang, revealing the hidden world of ideas beyond quantum mechanics and space-time. And these novel geometric objects recently discovered by theoretical physics hint at new mathematical structures. Combinatorics, algebra, and geometry have been connected to particle physics and to cosmology in an entirely unexpected way. Leveraging these advances, the team will launch the field of positive geometry as a new mathematical framework for describing the laws of physics. And as it happens, this week is the launching mathematical conference. So it's in Germany this week, and more than 100 mathematicians and mathematical physicists are launching this new endeavor to understand these positive geometries outside of space-time. So space-time is doomed, it's not fundamental, but these new positive geometries give you everything that you want inside space-time, and they're studying them. So that's just to summarize, space-time is doomed, but there are new geometries, these positive geometries outside of space-time that'll allow you to compute the scattering amplitudes. And by the way, they do it much more easily than you can do with quantum field theory. The mathematics becomes tremendously more easy, and you see new symmetries that you can't see inside space-time. So now to my theory of conscious agents with my collaborators, Chetan Prakash and many others that I've been working with. But I'll talk about, these are conscious agents now that are assumed to be outside of space-time. And so our big picture is this. Almost every theory of consciousness to date has assumed that space-time is fundamental and that it somehow provides the substrate from which consciousness emerges. We're saying our best physics and our best evolutionary theory tells us that that can't be right. Space-time is doomed. It is not fundamental. It is not the substrate for consciousness. It's in fact just a headset. So if we want to have a theory of consciousness, we need to have a theory of consciousness qua consciousness on its own terms, not as emergent from space-time. So we're proposing a dynamical system of conscious agents, a Markovian dynamical system, and we can go into the details of why. But this is not inside space-time, it's entirely outside of space-time. So we think about it as like a big social network of conscious agents entirely outside of space-time. And our task will then be to analyze the dynamics of this and show how space-time emerges from this dynamics. Because we have to make, of course, empirical predictions, and we can only test empirical predictions inside space-time, inside our headset. That's all we can see is inside our headset. So we need to see how space-time emerges, how the positive geometries first, the positive geometries that the physicists are finding outside of space-time, how they emerge, and then they take us into space-time from those positive geometries where we can make predictions for experiments. So the basic idea of a conscious agent, and we can go into the details in the Q&A if you have questions, is the point of our definition of a conscious agent is to be as minimal in our assumptions as possible, right? You can imagine lots of things going into theory of consciousness. We want to put in the minimal. So we're saying a conscious agent has some experiences, like maybe it experiences the color red. Maybe that's all it experiences. So a conscious agent may have only one experience. It experiences red, or it might experience the taste of chocolate and the smell of garlic or something like that. Based on its experience, it decides how it's going to act to affect the experiences of other agents in the network. That's it. So you have experiences, and then you decide how to act on and influence the experiences of other agents in the network, and they in turn act on your experiences. That's it. That's all we assume. So we're not assuming learning, memory, problem solving, anything like that. We're just assuming this very, very simple structure. And I should point out that the Markovian assumption is quite general as well. Any probabilistic process with a finite history, as big as you want, but as long as it's a finite history, can be modeled with Markov chains. You hear that Markov chains, your current state, your next state is dependent only on your current state. True, but your current state could be made as big as you want. It could be made arbitrarily large. So these are the only limitation on a Markov dynamical system is that it's not an infinite memory. But our universe has only a finite history, so infinite memory is not needed. So again, a theory of consciousness must explain tons of stuff. Here's a little wish list of things it must explain. But all we've picked out is a couple things. Qualia and actions, basically the ability to have qualia and the ability to act on the qualia of other conscious agents. Everything else here we have to explain. So we're not assuming it, we're going to have to explain it. But no problem in principle, because it's trivial to prove that conscious agent networks, these Markov networks, are computationally universal. So anything that can be done with a neural network can be done with a conscious agent network. And actually, they're not limited to computation. For technical reasons, if you're interested, we can go into, they can actually do things beyond computation. So one of the interesting things that you can do with this theory of conscious agents is study the social networks of conscious agents and look at how they interact and how they relate. And we have a nice notion of observation that comes out of this. And just to hint at that notion, I'll show you this little. Here's a agent that can only see 9 different colors, right? And I'm actually running a Markovian process in which each color that gets bigger is the color that the agent is seeing right now. And then you can sort of look at this and see, well, if I see red now, what's the probability that I'll see green next, or blue, or yellow, or whatever. So it's governed by some Markovian dynamical system. And so these 9 colors are just the 9 possible states of the Markov chain. But now you'll see that I sort of darken out 5 of them sometimes and only pay attention to these 4. So when we do that, what we can do is ask about what's the Markovian dynamics that's induced on just these 4 when you can't see the other 5. And you can then get what's called the trace of the bigger 9-state Markov chain onto this little subset of 4 states. And that's called a trace chain. And that will also, again, be a Markovian kernel. And there's a mathematical equation for this. If P is the Markovian kernel, and I've sort of schematically shown the kernel as a big box there. So P is the box, it's a square matrix. And I want to take the trace on A. So A is a subset, a subset of states of P. Then there's the little formula. So there are these submatrices that I've labeled A, B, C, and D. And P sub A is the trace chain that's induced on the set A and is given by this little formula. So there's a nice simple formula for taking a bigger Markovian kernel and finding how it projects into smaller kernels by this trace operation. It turns out that, and this is something that we're going to be publishing in a paper we're writing right now, we discovered that this is actually a partial order. So this is a new result in the theory of Markov chains. The trace relationship is a partial order. So a Markovian kernel M is less than or equal to a kernel N in this order, if and only if M is a trace chain of N. So, so we'll be publishing this, and this gives us a theory of observation, which we're going to need because we want to show how we model observations in a theory of consciousness outside of space-time, so that we can use those observations to be tested inside space-time. So if M is a trace of N, then we say that M observes N, and the logic that comes out of this is non-Boolean. In fact, it's more general than the orthocomplemented lattices that are used in quantum logics. It's just more general than that. So it's non-Boolean, but it's locally Boolean. If you look at all the kernels that are less than a particular kernel M, they form a Boolean sublogic, but the global logic is not Boolean. It has no highest unit, for example, and no negation, no complement in general. So we have a theory of observation that we'll be publishing that comes out of this, and we'll be using the theory of observation to make predictions. So the big picture then is this, that we have this network of conscious agents. Think of it as a big social network outside of space-time, like the Twitterverse, where agents are affecting each other's experiences, like a Twitter user tweets and follows and so forth. The experiences are like the tweets that are being passed around. Now, we proved in a paper that came out last year that we can map our dynamical system of conscious agents onto the decorated permutations, the same combinatorial objects that the high energy theoretical physicists are using to classify their positive geometries. And that's why we did this. Our goal, we want to make connections with space-time where we can make predictions that are testable. So we have to be able to do something like predict scattering amplitudes, like gluon scattering inside space-time from a theory of conscious agents outside space-time. So notice the difference. Instead of starting with a theory of space and time and physical object and trying to get predictions about consciousness, we're starting with a theory of consciousness entirely outside of space and time. And then we're saying that space-time is just a fairly trivial headset that some conscious agents use. But we can now show you how conscious agents create that headset, and then we can actually show you then predictions about particle scattering and other things inside that headset. So our paper called Fusions of Consciousness that came out last year shows how to map our Markovian dynamics onto decorated permutations. We're now working on connecting entirely with the positive geometries that the physicists are working on themselves, and making predictions inside spacetime that I'll talk about. So we start with conscious agents. We've already got the map to decorated permutations that's published, and we're working on getting the map through positive geometries like the amplituhedron into spacetime, where we can actually predict properties of particles, for example, in spacetime. I'm going to go through, for time, I'm going to go through this part pretty quickly. Some of the mathematical analysis, if people want some details, we can do it in the Q&A. But we can take multiple agents and fuse them, and so there's a famous problem in consciousness about combining subjects and experiences, and in many philosophical papers, it's been said that just can't be done, and the mathematics of conscious agents begs to differ. It gives us clean mathematical ways of combining conscious agents as well as their experiences, combining and fusing experiences. So we can talk about the details of that. The nice thing about having a mathematical model is that the mathematics then guides you on these things. So again, these are technical things that I won't go into. I'll just mention briefly that some of the connections that we've made so far, and we've published some of these last year, is that in trying to make a map between the Markovian dynamics of conscious agents outside of spacetime and particular properties of particles inside spacetime, quantum particles, some of the tentative mappings that we're making right now are quite interesting. That the mass of a particle is going to correspond to the entropy rate of a recurrent communicating class of conscious agent dynamics. The momentum will correspond to the number of states. Spin is a function of the determinant of the Markovian dynamical system. the determinants in Markov chains go from -1 to 1. And distances, space-time distances, are related to the commuting times. So in other words, what we're going to have to do is give a dictionary that says, oh, okay, space-time is not fundamental, consciousness is. And it's a Markovian dynamic. So what are the fundamental properties of a Markovian dynamics? Well, there are things like what are the recurrent communicating classes, what are the entropy rates, what are the determinants, what are the commuting times, and so forth. And so we're getting a map from those things into the particle properties that we see inside spacetime. And so one of our goals then is to actually make predictions about momentum distributions of particles. And I should say why we're going after that. You might say, well, if you're going to go after a prediction inside spacetime, why not go after the neural correlates of consciousness in the brain? Why don't you try to predict those? And ultimately, of course, we would like to. And the idea would be that the brain does not create conscious experiences. The brain, in fact, doesn't even exist when it's not perceived, right? It's just an icon in your headset. It's a virtual reality headset, and sometimes we see brains and neurons, and other times when we don't look, we don't see them, and then they're not there. So our theory makes a really strong prediction, clean prediction. Neurons do not exist when they're not perceived. Neurons have no causal powers. And by the way, I'm a cognitive neuroscientist. I love neuroscience, cognitive neuroscience. But what I'm saying is that neuroscience has seemed very, very difficult, but it's much, much more difficult than we ever thought. 86 billion neurons and roughly the same number of glial cells and many thousands of different kinds of cells seems complicated enough. But what we're saying is the brain is just a user interface symbol of some reality that's much, much deeper and much, much more complicated. So we're going to need more funding for neuroscience, not less, because we thought we see neurons and that's all we have to deal with is neurons. No, neurons are just the interface representation of a much, much more complicated reality. So neuroscience is going to be far more complicated. So I don't want to start there and trying to make my predictions. We're going after fundamental particles because there's lots of data about them from colliders, and because that's the simplest thing inside our headset that we can go after, which isn't to say it's simple, but it's the simplest thing. So, matter, as you know, is made of molecules, which is made of atoms, which are made of nuclei and electrons, and the nuclei are made of neutrons and protons, and neutrons are made of an up quark and two down quarks, and the proton is made of two up quarks and a down quark. And when you look inside a proton at various spatial and temporal resolutions, what the physicists call, for the spatial resolution, they call it Q squared, and the temporal resolution, they call it Bjork and X. So as you look at various Q squared and Bjork and X, you see at the lowest resolution inside the proton, you see the momentum distributions of the particles you see is dominated by three valence quarks, the two up quarks and a down quark. As you increase the resolution in space and time, you start to see what they call a quark sea. Lots of quark-antiquark pairs appearing and annihilating, and a bunch of gluons floating around. And then at the highest spatial and temporal resolutions, you get what they call a gluon sea. It's primarily these bosons, these gluons that are they're massless, so they're moving at the speed of light. This is quite frenetic. And they dominate what's going on there. So there are momentum distributions that have been gathered over decades of careful experimental research. And so our goal is to use a theory of conscious agents to predict precisely the momentum distributions at all Bjork and X and Q squared. That'll be a first acid test for this theory of conscious agents. So it's not like, because we're starting outside of space-time, we're free, we don't get to make any empirical predictions that might falsify us. No, we're going after these momentum distributions, and if we can't do it, then there's something wrong with our theory, just that simple. So that's where we're headed, is to study the momentum distributions of quarks and gluons inside the proton, and see what dynamical system of conscious agents would model that precisely. So for those who want to see a little bit more background of what I've been talking about here, we have a paper, Fusions of Consciousness, where we introduce the map from Markov chains to decorated permutations. So that's a new contribution to the theory of Markov chains, but it's also critical to us doing this empirical test of our theory, where we go from Markovian dynamics through decorated permutations, through the positive geometries into space-time, where we can make the explicit tests of our theory. So I want to leave plenty of time for questions and answers. I want to give thanks to a number of my collaborators. I would especially give thanks to Chetan Prakash and Ben Gnepper and Schwapon Chattopadhyay and Robert Prentner for their close collaborators in the last year and a half on this stuff. So special thanks to them. And with that, I'll stop the share. And I think if I can't see my screen. Let's see. Huh. There we go. Stop share. Okay.
All right. Thank you very much, Donald, for that fantastic talk. Greatly appreciated. And now for the poll results. So let's first end the poll. And I could share these results. So hopefully you're seeing this on the screen.
Wow.
So the first question was, consciousness is fundamental and causes brain activity. 58% of the participants said yes, uh, which is quite unbelievable for me and for this kind of academic audience, I must say. The second question was, a reality may be completely different from what our brains model and perceive. And 96% answered yes, which
Wow.
is 43 out of 45 participants. Again, a very remarkable result. So let me stop sharing the poll and let's get to a little bit of Q&A. So while the questions are flowing in, just again, another reminder for everyone to post your questions through the Q&A button. I would just like to take this opportunity to maybe ask you, Don, about what your perspective is on what exactly is consciousness. I mean, you spoke about conscious agents, and there are a few questions about that. So I'll save that those questions to later. But what, according to you, is consciousness, and what is that reality which lies beyond that headset of space and time?
Well, as a scientist, what I have to do, of course, is to start proposing mathematical definitions, right? And of course, any mathematical definition will only just be my current theory, and it will never be the truth. And that's sort of a very important point. There can never be a theory of everything. So, and the reason is simple, that a scientific theory says, if you grant me these assumptions, then I can use those assumptions to explain all this wonderful stuff. But the theory doesn't explain its assumptions, it assumes its assumptions. And so you can say, well, but of course I can give you a deeper theory that explains those assumptions. Indeed, you can, and your new theory will have its own assumptions. So there's infinite job security in science, because there will never be a theory of everything. And so my attitude about what is consciousness, I can say informally what I think as a human being. I can say formally what my current mathematical model is, but I can say this, that what I'm going to say today will be merely a baby step, and that what we'll be doing in science, I think, is a never-ending process of trying to answer your question. Okay, so I think that, but I've sort of given today just a quick overview of the theory of consciousness that we have. The key parts of that theory are that conscious experiences are taken as fundamental qualia, the experience of red and so forth, and the idea that there are fundamental probabilistic relationships among experiences of different agents. So those are the only ingredients that we assume: qualia and probabilistic interactions of qualia. So no specific notion of intelligence, learning, memory, problem solving, the self, none of that stuff is assumed as fundamental. And this is all just in the spirit of science of making the minimal assumptions that you possibly can, right? You don't want to assume the kitchen sink. You want to build the kitchen sink. You want to throw it in at the start. So you want to build the kitchen sink, not assume it. So we assumed as little as we can. So now intuitively, going beyond our current theory, I would just say my view about our current theory that I proposed today, what's nice about it is it's mathematically precise. There's no ambiguity in its definition. It's absolutely precise, and we can produce theorems and so forth. But I view it as just the first baby step, just a first baby step towards a theory of consciousness, and that even if we had a billion Einsteins working for a billion years, we would not be done. And so I actually, now I'll say my intuition about why we'll never be done. It's related to the fact that there can't be a scientific theory of everything, that we'll always be creating deeper and deeper theories. There's something infinitely deep about consciousness. I think it transcends mathematics, and it transcends any theories that we could possibly. What we can do, I think, at best as scientists is build mathematical models of certain projections of consciousness. And that's probably all we have ever done is build mathematical models of projections of reality. And for some reason, they turn out to be very useful. They're, in some sense, what we're doing is modeling our headset. So think about, the big reality is this consciousness, and it looks at itself through various headsets. And what science can do is model how this particular headset might work. So that's where we get the feedback that tells us, well, no, so it's not, is our model the truth? It's rather, is our model a good model of our particular projection, our particular headset through which we're looking at the truth? So long answer to your question. You can see why I had to give a long answer.
Right. And just to clarify, could we study the headset and the rules that govern the headset and the way the headset is programmed within your model?
Yes. And that's going to be really interesting because, again, networks of conscious agents are computationally universal. So we can actually build a headset using the network itself. Now, here's what's really going to be interesting about doing that. Not going to be easy. We'll have to do little baby models to begin with, right? We're not going to be building a complete headset. But ultimately, what I'd like to do is to build as comprehensive a headset as we can, and then have that headset look at itself, look at the very network that implements it, and see what that network looks like to it. And the prediction will be, it will look like brains and neurons. So brains and neurons are what we see when we take our headset and look at the network of neurons that's creating that headset. So neurons are not the reality. Neurons are just the image in our headset of the actual network of conscious agents that's building the headset. So that's why neuroscience is going to be much more complicated than we thought. So this is job security for neuroscience.
Very interesting. All right, we have plenty of questions, so I hope you're able to stay for at least an hour longer. Just joking. Okay, so many of the participants have this question on conscious agents. Okay, so what, firstly, could you give your expanded definition of consciousness within your framework? That's what Yanina asks. Akhanditi Das asks, what exactly is the notion of a conscious agent? Is it a specific qualitative experience, or is it the agent or entity that possesses consciousness and experiences the qualitative conscious event? Another user asks, the participant asks whether they are neurons, right? Whether a conscious agent is a neuron. So yes, many questions about conscious agents. Could you please clarify that concept for us?
Right. Well, the last one is the easiest. So conscious agents are not neurons. Neurons are interface or headset symbols that we use when we interact with certain sets of conscious agents. So neurons are just one little headset description of conscious agents. Now, I should say that so what is a conscious agent? There's the technical definition in our paper, and for those who want to actually see the precise mathematical technical definition, we have a paper called Objects of Consciousness. So if you Google, my name, Donald Hoffman, and objects of consciousness, it's available free online, so you can read the exact definition. But the definition is that the the space of qualia is a so-called measurable space, the probability space. The space of actions is also a measurable space. And those arrows in my diagram, I showed those, the qualia, the actions, and the network of agents, and then there were arrows. Those arrows are Markovian kernels. So that's the mathematical definition. It's basically the definition of a conscious agent is three kernels, three Markovian kernels. Or you can view it as one Markovian kernel if you take the composition of those. You can take compositions of Markovian kernels, so you can compose them into what we call the qualia kernel. So you can also view a conscious agent as a single Markovian kernel. So that's sort of a technical answer. Intuitively, uh, the way I think about the mathematics and its relationship to consciousness is the probability space. You have to write down a probability space to do probability, right? But the probability space is there before you actually do anything, before you have any experiences, before you do any actions. The probability space is just sitting there. So I think of that as awareness without content. So that part of the mathematics is modeling what many spiritual traditions would talk about as a primordial awareness prior to any particular experiences. And the mathematics, by the way, I didn't write down the mathematics to model that. I wrote down the mathematics because I had to, and a decade later, I realized that it had that interpretation. So I was very, very slow to see that it had that interpretation. So I'm forced to write down the probability space before I can even write down my Markovian kernels and the dynamics. And so I view that as so each probability space is a sort of a finite little piece of the full awareness of consciousness, right? Because my little probability spaces aren't infinite, but I would think that the full awareness thing is in some sense infinite. So now I should say something else. I'm talking about these little conscious agents that might have only one experience, and then they can combine. And by the way, the trace order that I mentioned, the trace chain order, gives you the rules for combining agents. That logical structure is the logic of how you combine consciousnesses. It's really beautiful. So we're working to write that up and publish it this year. So that's how you combine. But what it tells us is that many spiritual traditions talk about the one consciousness. Well, this trace order is going to give us our first scientific description of quote unquote the one, because it tells you all the possible ways that consciousnesses could combine. It describes it. And it's going to be complicated because if you have a countable set of conscious agents, there are so an Aleph zero set of conscious agents to start with. There is an Aleph one set of possible combinations. Now, so we look at those. Now, if we take the Aleph one set of new agents, there's an Aleph two set of possible agents that come from them. So, in other words, to understand consciousness deeply, we would have to go up all of Cantor's hierarchy, combining agents and so forth. So that's another reason why I said our theory is just a baby step. But it's an interesting baby step because it tells you immediately that our theory is just a pointer to an infinite complex lattice. Well, it's not, yeah, it's a non-Boolean logic, of conscious agents with no top. And you'll have to climb up all of Cantor's hierarchy to explore it. So that's why I have to very modestly say this is just a first baby step. But what's good about the baby step is it's pointing to its own limits. It's saying, oh boy, you have a lot of work ahead, and this theory it says there's a lot of work ahead, and you probably will never be able to describe the one consciousness. That may be something that science cannot do.
Again, sounds very fantastic. Thank you for that elaborate description. But I kind of understand why there might be some confusion is because you gave some hints about or analogy with virtual reality goggles, right?
Right.
Where there is a person wearing that goggle.
Yes.
And so that kind of becomes the reality behind the headset, right? So is it a
Right.
person? Is it something else? And this is related to, actually, there
Okay.
are two questions related to this. What happens to our perceived consciousness within your model, if at all there is any answer? What happens to our perceived consciousness upon death?
Mhm.
And a related question is that could we start probing some aspects of this deeper reality through meditation experiments, right? Because you brought in spiritual traditions, but then, of course, meditation is a means of accessing higher states of consciousness, which I'm not sure how you deal with in your theory. But do you have any insights into these two different questions? One is um, consciousness upon death and mind-based experiments to probe that higher reality.
Right. So physicalism, of course, makes a clean prediction about what happens to your consciousness at death. Your conscious experiences are entirely generated by some physical substrate, presumably the brain. And when that substrate disintegrates, so does your consciousness. Clean prediction. No survival. This theory says that space-time is not fundamental. Our best science tells us now. High energy theoretical physics and evolution by natural selection tell us the assumption that space-time is fundamental is false. It's just plain false. It's contradicted by our best science. Now, what the next theory should be, who knows? Well, I'm not saying I'm right, and it's only been 10 years that we've been starting to look outside space-time, so all bets are off. But here's what our theory entails. It's saying that consciousness is fundamental, and so what death is simply taking off a particular headset. So consciousness is looking at itself. You might say, well, why does consciousness need to have these headsets, right? Why does consciousness even need headsets? And and I don't know, but here's an interesting take on it. Um, it's a theorem that no system can know itself completely. If I have a computer system and I try to say I want this system to represent itself, well, it's going to build a model of itself, some software model of itself. And in the process, it becomes more complicated. So now it doesn't have a model, it has a model of its prior self, but not of its current self. So now you need a more complicated model. So you're going to get an infinite regress, right? No system can really ever understand itself completely. All it can do is get perspectives on itself. So that maybe that's what consciousness is doing. The one infinite consciousness can never fully understand itself, but it can look at itself through different perspectives. And so it looks at itself through different headsets. And um, space-time is actually, one of the more trivial headsets. And I say that technically. The amplitude-hedron that I mentioned, this positive geometry that the physicists have found, one of the parameters of that amplitude-hedron is a number they call m. For our headset, for our space-time, m is 4. But their theory says this positive geometry, m could be 8, it could be a billion, it could be a trillion. 4 is one of the more trivial versions of it, but that's the version we're stuck with right now. We're stuck with 4. So when I say that we actually have a trivial headset, the new positive geometries are giving us a clue that yes, there are far more interesting headsets out there, and 4 is pretty, we got cheated. We got the cheap model. So consciousness, in some sense, may be looking at itself through different headsets because it's understanding itself from different perspectives. And part of understanding itself may be losing itself in a perspective, letting itself completely identify with a particular perspective and believe that I am my avatar in this headset. I believe that I am that avatar. And then slowly waking up. And that way it takes that perspective very, very seriously. It sees all the richness of that perspective. And then it wakes up and says, I transcend even that. So whatever I am even deeper than that. And so that's how it gets to know itself. So death may be the death just of your avatar, and maybe death of addiction to space-time, but not death of consciousness, your consciousness itself. Um, and meditation then would be part of this waking up process that is intrinsic to what consciousness is up to. It's meditation is one of the tools we can use to learn to enjoy the beauty and complexity of this headset, and then to realize that I am not my avatar, and then to transcend it. Uh, and then perhaps hopefully go to a more interesting, I mean, m equals 4, this is just a 4-dimensional space-time. So I'd like to move on to more interesting headsets. This is a pretty cheap one.
Very interesting. Maybe we have time for a couple more questions, but
Sure.
one of the questions related with what a participant, Joseph Store, is asking here, and another participant is you just referred to mathematics of conscious agents. So does it mean that mathematics and perhaps even geometries may lie beyond physical space-time? Maybe there is some other form of reality which accommodates these aspects, just not physical space-time.
Yes, and that's what this new Universe Plus initiative from the European Research Council is doing, right? This week, literally this week, they have their launching conference, and there's over 100 mathematicians and mathematical physicists who are actually already giving papers about the positive geometries that are utterly outside spacetime. So these are not geometric objects inside spacetime. These are prior to spacetime, and by the way, prior to quantum theory. So there, put it this way, there are no Hilbert spaces here. There is no quantum theory here. Quantum theory arises, actually, unitarity arises in the projection due to the face structure of these positive geometries. So it comes out as just a part of these, an interesting aspect of these positive geometries. So yeah, I'll just stop there. Yeah.
Excellent. All right. This one last question. And I must mention here that there have been 25 or more questions. Actually, it's impossible to reach all of these to completeness, but
Sure.
this is a record number of questions. I'd like to mention that. So, Don, everyone is interested in all of these topics. So, thank you very much for that very
Yeah.
thought-provoking presentation again. But if we were to end with one final question, it would be in terms of does this theory that the mathematical aspect that you have predict anything about consciousness being expressed in different species? And what would
Ah,
be, this is related to what Hua Wu here is asking, but how could we predict consciousness within different species? And what are the implications for robots being conscious?
great question. A very important question. So in a physicalist framework, the idea is that at the Big Bang, there was no consciousness. There was just physical stuff, energy. And eventually, after millions or billions of years, life emerged. And then eventually that life got complicated enough that somehow it got consciousness. That's the physicalist framework. So in that framework, it's certainly legitimate to ask, uh, how do we distinguish between living and non-living things? And how we distinguish between conscious and unconscious things as well. That makes perfect sense in that framework. But space-time is not fundamental. It's just a headset. And if that's the case, and consciousness is fundamental, then the distinction that we make between living and non-living, or between conscious and unconscious, is not a principal distinction. I'm pausing because that's really important. Right now, for example, I'm looking at my Zoom screen, and I see, Kunal, I see your face, pick some pixels for your face, and some pictures of the Golden Gate Bridge and the sky and so forth. So I might say, well, some of the pixels on my screen are conscious pixels, and some of them are the face pixels for Kunal's face, and others are unconscious pixels. Well, that would be dumb. Pixels are just pixels. They're not conscious or unconscious. They're part of my interface. Pixels are just pixels. And that's when I say the distinction between living and non-living, conscious and unconscious, is not principled. It's an illusion. And so theories of consciousness that claim that there's a principal distinction between systems that are conscious and ones that are not conscious is making the same mistake as me saying certain pixels on my screen are conscious and other pixels are not conscious. Big, big mistake. So you can see this change of framework has huge consequences. So now, when we go to artificial intelligence and ask the question, could we build conscious AIs? The way that that question is usually thought about is in the old and now moribund framework in which space-time is fundamental. In that framework, we're again thinking of physical systems that are unconscious, getting complicated enough, having the right amount of integrated information, whatever it might be, to the right global workspace architecture or the right orchestrated collapse of neuronal microtubule quantum states, whatever it might be. If they have the right kind of physical structure, then consciousness will emerge. And so the question is typically, how can we give unconscious computer circuits the right causal structure, say in IIT, to become conscious? And so they're going to have what some maximally irreducible intrinsic causal effect structure of a mechanism for for integrated information to actually be conscious. I'm saying that whole approach is entirely wrong. Nothing to be salvaged at all. It's wrong from the get-go. What we have in our headset, when I look at Canal right now, my headset has a portal into the consciousness of Canal. That portal is what I call the face of Canal, and it's actually on my Zoom screen. So it's on my Zoom screen interface, and then there's the face of Canal. And then I can tell if Canal is interested, if he's bored. I get some fallible but genuine insight into the conscious experiences of Canal. When I look at a cat, I get less insight, but some. My headset gives me some. When I look at an ant, even less. When I look at a rock, my headset is given up, right? But that's to be expected. That's what headsets are there for. They're there to simplify things. A user interface is there to dumb things down because you don't want to deal with the complexity. So of course, at some point, it's not going to look conscious, but you're always interacting with consciousnesses. So you can see I have to change the whole question about AI. The question now is this, not how do unconscious physical circuits get the right integrated information properties to become conscious or whatever it might be. The question is this, we know that we have certain portals into consciousness, like faces, bodies, and so forth. And we know that we have one technology. We know of one technology for creating new portals into consciousness. That one technology that we know is having kids. So we do have a technology for creating new portals in our headset into new consciousnesses. So the question is, if we understand our headset well enough, can we reverse engineer it and then figure out how to create new portals into our headset, into the consciousness behind? For what it's worth, I think yes. I think we will be able to reverse engineer the headset and be able to create new portals into consciousness. And the resulting technology may look like artificial intelligences, quite possibly, but it will not be a technology in which unconscious circuits and software are somehow giving rise to consciousness. It will be a technology in which conscious agents have rejigged a particularly trivial user interface, namely our four-dimensional space-time headset, which is trivial compared to what could be out there, and opened up new portals into the pre-existing consciousnesses. So no new consciousnesses are being created. We're just opening up new portals into the consciousnesses that were already there. And by the way, if this whole approach is true, think about it this way. Suppose you're a wizard at Grand Theft Auto. You can drive the cars faster than anybody. You can go anywhere you want to. You can beat all the other players in Grand Theft Auto. You're really proud of yourself. You really have mastered that game. Well, but if I'm the software engineer that wrote Grand Theft Auto, and I know the software, I can do stuff that would be magical to the wizard. I could take the gas out of his tank. I could change the geometry of the roads. I could give him a flat. I could do anything. Right now, we've assumed that space-time is fundamental. when we recognize that it's just a headset and we start to look at the conscious agent software outside of the headset, we're going to be like those wizards outside the headset, the software engineers outside. We won't have to, for example, right now, to go to the nearest galaxy, the Andromeda galaxy, would take 4 million years at the speed of light. Oh, no, I'm sorry, 2.5 million. I'll just say that I don't know the exact number, millions of years. It takes millions of years to get to the nearest galaxy going through space-time if we could go at the speed of light. But if you have the software, you don't have to go through space-time. You can go around space-time. So I predict technologies in which we don't go from here to, we don't have to travel through space-time. We can travel around space-time. So the technologies that are going to come out of this will be truly stunning, including things that look like artificial intelligences that are conscious, but it will not be a bottom-up physics gives rise to consciousness. It'll be the other way around. We've opened new portals into headset to consciousnesses that were already there.
Very interesting. All right. So I think we are way up with our 1 hour of colloquium and Q&A, but nevertheless, it was very, very fascinating. I just want to make some few announcements before we end. And so the next colloquium in the Consciousness and Reality series will be in March next month. So stay tuned for more details on that. And Dawn, we may organize a session with students and postdocs. So in case you're available, uh, it'll be a very nice interaction and Q&A session, sort of extended like an hour worth of session. So if you're available for that, we'd very much be grateful for uh, another Zoom session specifically with students and postdocs.
So
So
we
I
would, so not today, but at another time.
some other time I'll let you know. Yes.
Absolutely. Yeah, I would love to do that. Absolutely.
Excellent. Thanks so much. And finally, I would really like to thank again Donald Hoffman, Dr. Shemrolu here, another member of the panelist, and all organizers, as well as all participants who made this event happen. Have a great day, everyone.
Thank you.
Thank you.